Whereas matrix addition and matrix scalar multiplication are pretty much the same as with vectors, matrix multiplication is entirely unlike vector stuff. So let's define what it is. If A is m by n and B is n by r, then A times B is the m by r matrix whose ij entry is given as follows. It's AI1 times B1j plus AI2 times B2j plus plus AIN times BNJ. Notice here that this 1 and this 1 are the same, this 2 and this 2 are the same, this n and this n are the same. If you know summation notation, this is the same as the sum from k equals 1 through n of AIK BKJ. So again, we have this k here, this k, and this k here. An easier way to remember this is that it's the dot product of the ith row of A with the jth column of A. So again, this is the dot product. Let me box all this. Make it a little bit longer. Very important thing to notice here. The number of columns of A must equal the number of rows of B. That is critical. Otherwise, matrix multiplication is not defined. So if the number of columns of A were not equal to the number of rows of B, then A times B would not be defined. So to remember when things are defined and what size matrix you end up with, you can kind of abbreviate this as A times B. So if this guy here, this is going to be an M by N matrix, and this is an N by R. So these two N's are the same. So these two N's are the same. And this equals A times B, where this is an M by R matrix. This M comes from over here, and this R comes from over here. So this may seem a rather strange definition, but it turns out to be extremely useful. There is something called component-wise multiplication, but it turns out that that's not very useful at all. So let's do some examples. So let's take a look at the product that will magically appear on the screen in just a second. So the first thing we need to check whenever we have a matrix product is we need to make sure it's actually defined. So let's figure that out. Well, this guy here, this is a 2 by 3 matrix, and this is a 3 by 4 matrix. Well, this 3 and that 3 are the same, and so this product is indeed defined. And to figure out, well, what is the size of the matrix we get? Well, we look at this 2 and this 4, and so it's going to be a 2 by 4 matrix. Well, now let's actually go ahead and compute it. Well, we have this first row dotted with this first column, so that's going to be 1 plus 4 plus 3. Then we have for over here, for the first row's second column, we have the first row of the first matrix dotted with the second column of the second matrix. That's -1 plus 0 plus 3. Then similarly we have 3 plus 0 plus 3 and 1 plus 0 plus 3. Then for our second row, now we do that with this second row of the first matrix and then repeat stuff. So here this is going to be this. So again, notice that this is a 2 by 4 matrix. And when we simplify everything, we get this matrix. So now let's look at this guy. First thing I need to do is check to make sure that this is a well-defined product. So this product does exist. Well, this is 1 by 3 and this is 3 by 1. Let's see. Well, 3, those are equal. Great, so this product exists. And when I do it, well, it's just the dot product of this row and this column. So that's going to be the matrix with one entry. It's 4 plus 10 plus 18, which is 32. On the other hand, let's see what happens when we try and do this product. Well, let's see, is this defined? Well, we have a 3 by 1 matrix and a 1 by 3 matrix. And we look at the middle guys here, and those are the same. So yes, this is defined. However, whereas this example, when I did the multiplication in this order, I ended up with a 1 by 1 matrix. Here, in this example, I'm going to end up with a 3 by 3 matrix. Let's see what that matrix is. Well, when I do the multiplication, I get this matrix here.